So today we're going to get an introduction to the periodic table, the structure of the table, what it looks like, how to read it, and we're going to kind of be able to see the major features of it, the metals, the nonmetals, and the metalloids, and how they relate to the chemistry of the elements of the Earth and the chemistry of us. So here we have the periodic table. This is a listing of all the different elements, and as you can see, the human body is composed of quite a few different things. But most of the body is composed from elements that are lighter, so elements that have less protons and less neutrons. And you can kind of see pretty clearly that we are a lot of oxygen, we have some carbon in us, a little bit of nitrogen, we have some hydrogen right here, as well as maybe some of these metals over here, nitrogen, calcium, and potassium, and we have a faint bit of iron, but almost nothing of the heavy elements. You can see that the soil of our planet is a mixture also of many elements, but it's a pretty good representation, just like our body is, that elements above iron are pretty rare on our planet. So elements that are heavier than iron simply don't show up very much. They're not in high abundance in our soil or really in the earth. And that most of our Earth, once again, is composed of these lighter elements like oxygen and silicon, with some other metals thrown in like iron, calcium, potassium, magnesium, sodium, aluminum. Okay, so if we're going to begin looking at the periodic table in more detail and trying to understand some things about the periodic table, one of the first things that we should do is appreciate its structure. So the periodic table is like a map, just like a map of North America. In that everything has a place and that you actually can't move anything, because if you were to try and move something, like take phosphorus for instance, and you wanted to move it down to where indium is, not only would phosphorus's information be inaccurate, but in fact the entire table would be wrong at that point. Everything in this table is built in a very specific way, so that they're all stacked in a specific way, so the things above and below elements, they have meaning, as well as the fact that the table reads from left to right in a very specific way as well. And so just in the same way that no map that replaced Florida with Georgia would ever be considered something you'd want to be utilizing to give you directions, the periodic table in its own way has to be appreciated for the way it is built. Okay, so we can look at the periodic table in a lot of different ways, and we can get a lot of information from this particular table of elements. But one of the easiest things we can do is we can group the elements into three major categories. And this is basically grouping them by their properties. So we have, first and foremost, we have the metals. So metals compose most of the table. Actually, hydrogen is kind of an off element. We shouldn't really include hydrogen in that. And so the metals are often lustrous, they're shiny, they conduct electricity quite well, they're good conductors of heat, and they're malleable, so you can typically, their atomic structure allows you to kind of shape them into different things. And so you can see this is a picture of probably copper and iron and chromium, probably some dashed in gold in there every once in a while. So a lot of different metal elements, all molded into different shapes, but all of which would conduct electricity pretty well and conduct heat pretty well. The nonmetals are elements that exist up here in blue, and these elements are characterized by being particularly poor electrical conductors, and they're also really bad at conducting heat. And so when you want to make something like a scarf, or this to have a fuzzy sweater for the baby, you don't want something that's going to conduct heat away from the baby, because the baby is generating its own heat, and so you don't want that heat to be effectively transmitted out of the baby into the cold air. And so you generate typically things of scarf and clothing out of stuff like carbon and oxygen, and these elements are quite bad at conducting heat, so the heat stays in the baby as opposed to being effectively transmitted out. So finally, we have the metalloids, and these are a stair-stepping group of different elements that kind of have metal-like properties, and they're also kind of non-metal-like properties. So depending upon the circumstances, they are either good conductors or they're bad conductors of electricity and heat. And I think that for just a handful of elements, one would think this is not that important or not that interesting, but however, actually, the ability to selectively electrons flow across elements is incredibly important for our technology industry. And a great example of this are things like silicon chips. So most of our chips these days are made out of silicon or germanium, which are these elements right here, and there's a lot of investigations into the surrounding elements as well. And so these elements are quite good at in certain circumstances allowing electrons to flow through them, and then in other circumstances not allowing electrons to flow through them, and so we can kind of have this on-off situation, which is good when you're trying to store information. Okay, so we can look at the periodic table and we can say, well, it's a lot of metals, and there's a tiny bit of these metalloids, and on the far right side that we have these non-metals. So we can look at it that way. We can also look at it in some other ways. In particular, we can read the table like a book. So you can start up here. You can start by looking at hydrogen. Hydrogen is the first element. It's the smallest element possible. It has one proton. And then you can go from left to right, just like you would in a book, going to the next element, helium. Helium has 2 protons. And then lithium, shocker, has 3. Beryllium has 4. And basically, you'll notice as you move along the table that the difference in elements is simply adding 1 more proton. Another way to talk about the periodic table is that there's similarities and differences depending upon columns and rows. So if you are on the same row, then you're typically called a period. So this is period number 1. This is period number 2, 3, 4, 5, 6, and 7. And so a period 2 science would be something that investigates maybe carbon or nitrogen or oxygen or fluorine or neon. Something if you wanted to look at period 3 chemistry, then maybe you were interested in phosphorus or silicon or aluminum. Alternatively, you can actually group elements by their columns. And they're actually called groups. You'll hear me also talk about them as columns. So you can see here that this would be a group number 13. So boron, aluminum, gallium, indium, and thallium are all in the same group. One thing that people often describe, because the table does read like a book, is that you can actually kind of imagine the whole table kind of as a cylinder, because it should actually seamlessly go from helium down to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and then once you get to neon should immediately jump over to sodium, which is number 11. And so as you count up, you should just remember that even though we sit, it looks like at the end of the page on group number 18, you really should just immediately think about moving down to the next period and continuing on in your reading, going directly from neon to sodium, going directly from argon down to potassium.